Welcome to the DIY Honda Garage channel. The error code P050A signifies a cold start idle air control system performance problem in the Honda Civic models from 2011 to 2015. This code indicates that the vehicle's idle air control IAC system is not performing as expected during cold start conditions. It typically affects components like the electronic throttle control ETC system, the mass airflow MAF sensor, and the intake air temperature IAT sensor, which are critical for regulating the engine's idle speed at startup. The IAC system regulates the amount of air entering the engine while idling, especially crucial during cold starts when the engine requires more air to maintain optimal performance. Identifying the root cause of this issue is essential for ensuring reliable vehicle operation and fuel efficiency. Diagnostics should begin with collecting all freeze data and onboard snapshots before proceeding with specific troubleshooting steps outlined in the service manual. DTC P050A signals a malfunction in the cold start idle air control system, which is pivotal during the engine's ignition phase. The idle air control IAC system is essential for maintaining the air-fuel mixture required for idle stability, especially during cold start conditions. This system comprises several components, including the throttle body, MAF sensor, and IAT sensor. The throttle body controls airflow into the engine, while the MAF sensor measures the amount of air entering the engine, and the IAT sensor monitors the temperature of the incoming air. These components are generally located in the engine compartment, connected through ducts that lead from the air intake to the engine. During cold starts, the vehicle's management system demands precise inputs from these sensors to optimize engine performance. If any of these components fail to provide accurate data or function correctly, it could trigger the P050A code. The potential causes for DTC P050A can range from issues in the MAF sensor or IAT sensor to blockages in the air intake pathway. A faulty MAF sensor can fail to deliver accurate air volume measurements, affecting the engine's air-fuel mixture during cold starts. Similarly, a bad IAT sensor might not relay accurate temperature data, which is essential for making adjustments to air intake. Another potential issue could stem from a contaminated or damaged throttle body, restricting airflow and negatively influencing idle control. Additionally, physical blockages or poor connections within the intake air duct can prevent the optimal flow of air, leading to performance problems. These components work synergistically as part of the vehicle's PGM-FI, programmed fuel injection system, so any failure in one can trigger broader system issues. Symptoms associated with DTC P050A may include rough idling characteristics, indicating that the engine struggles to maintain stable RPM during cold starts. Drivers may also experience poor engine performance immediately after starting, as the engine could stall or fail to respond smoothly to throttle inputs. While the check engine light is a visible warning, the reality is that performance issues may be noticed before the light activates. Unstable RPM can lead to rough vehicle operation and diminished fuel efficiency. Understanding these symptoms can help technicians diagnose and address the underlying issues before they escalate into more significant malfunctions. Each symptom is a direct reflection of the malfunction within the cold start idle air control system or related components. Begin troubleshooting by conducting a PGM-FI system check, which entails turning the ignition switch to the on position or 2. This action powers the vehicle's electronic systems without starting the engine. Next, utilize the Honda Diagnostic System, HDS, to check for any pending or confirmed DTCs beyond P050A. Identifying other DTCs is critical since they can provide insight into secondary issues impacting the idle air control system's performance. If other DTCs are indicated, referring to their respective troubleshooting steps becomes essential. If there are no other codes, technicians should proceed to the next step. This step is crucial as it helps to define the context and scope of the issue, alerting technicians to any coexisting problems that may need attention. In Step 2, the focus shifts to a visual examination of the intake air duct to ensure there are no poor connections or blockages hindering airflow. Technicians should inspect the duct for signs of wear, damage, or improper installation. Any obstruction, whether due to dirt or physical damage, must be addressed promptly, as it can severely impede the performance of the idle air control system. An unobstructed path for air intake is essential for measuring air volume accurately, as miscalculations can directly affect engine performance. If issues are found, repair or reconnect the duct appropriately. Once completed, proceed with the repair verification process to confirm functionality is restored. Ensuring the intake air duct is free of any interference is a fundamental step in resolving idle performance issues. Step 3 involves a visual check of the air cleaner housing. This component is critical as it houses the air filter that allows clean air to flow into the engine. Any obstructions, poor connections, or damages in this area can lead to inadequate airflow, which may trigger DTC P050A. Inspect the air cleaner housing for any signs of damage or loose fittings that may disrupt airflow. If the component is found to be faulty or blocked, it should be replaced to ensure proper air filtration and airflow. Tightening all connections is also essential to avoid any air leaks. After addressing issues, technicians should conduct repair verification to confirm that the problem has been resolved. A clean and functioning air cleaner housing is vital for effective engine performance, particularly during idle conditions. The fourth troubleshooting step focuses on the air cleaner element, which is critical for filtering out contaminants from the incoming air. Excess dirt and debris can clog the air filter, leading to reduced airflow and affecting engine performance, especially during cold starts. Technicians should examine the air cleaner element for dirt or other obstructions and assess its condition. If the filter is found to be dirty, it must be replaced to maintain optimal airflow and prevent the recurrence of performance issues. Ensuring proper air intake is vital for the accurate functioning of the IAC system. After replacing the air cleaner element, technicians should carry out repair verification to ensure that the system is operating correctly once again. A clean air cleaner element is essential for smooth engine operation and effective idle control. In Step 5, the engine must cool down until the value of the engine coolant temperature, ECT sensor 1, reaches 122 degrees or 50 degrees Celsius or less. This temperature is crucial for creating consistent test conditions. Once sufficiently cooled, it's necessary to clear the DTC using the Honda Diagnostics System, HDS. After clearing the code, start the engine and allow it to idle for a minimum of 10 seconds, watching closely as the vehicle operates. Monitoring the onboard diagnostics OBD status is essential to determine whether the HDS indicates that the DTC P050A has failed or passed. If it indicates passed, no further immediate actions are required, but intermittent issues should still be investigated. These verification steps are instrumental in confirming the successful resolution of the initially diagnosed problem. Step 6 requires performing the Electronic Throttle Control System (ETCS) test using the HDS. This test determines whether the throttle actuator control valve is functioning correctly, which is crucial for regulating engine airflow during idle conditions. If the actuator is functioning normally, technicians will proceed to the next step. However, if it is not functioning correctly, the throttle body must be replaced. The throttle body plays a vital role in managing the amount of air entering the engine, especially during cold starts, and any malfunction can significantly impact engine performance. After replacing the throttle body, the next step will call for performing a repair verification to ensure the issue is resolved. Successful completion of this step is essential for returning the engine to optimal operating conditions. Step 7 focuses on assessing the performance of the mass airflow MAF sensor. Begin by starting the engine and gradually increasing the speed to 3,000 revolutions per minute, RPM, without loading the engine. And maintain this speed until the radiator fan engages. Following this, allow the engine to return to idle. It is crucial during this process to monitor the MAF sensor data using the HDS, ensuring it reads between 7.0 8.6 grams per second, G per second. If the readings fall within this range, the MAF sensor is functioning correctly, and technicians can proceed to the next step in the troubleshooting process. If the sensor does not register appropriate readings, replacement of the MAF sensor or the IAT sensor may be necessary. Accurate performance from the MAF sensor is essential for proper idle control and overall engine efficiency. In Step 8, technicians must compare the value of the intake air temperature, IAT sensor, against the ambient temperature. Begin by turning off the ignition and allowing the engine to cool until it reaches ambient temperature. Afterward, turn the ignition back to the on position and quickly note the IAT sensor's value from the HDS data list. The difference between the IAT sensor value and ambient temperature should be less than 5.4 degrees Fahrenheit, 3 degrees Celsius. If the difference exceeds this threshold, it indicates a malfunctioning IAT sensor, which must be replaced. Conversely, if the values align appropriately, the IAT sensor is in good condition. However, this step should also include inspection for any dirt, carbon buildup, or damage in the throttle body. Cleaning or replacing the throttle body might be necessary based upon this assessment. Monitoring IAT readings is crucial for maintaining effective engine operation during various conditions. The final repair verification consists of several critical steps. Start by ensuring that all connectors related to the repairs performed are correctly reconnected. This is an important step because loose or ineffective connections can lead to the reappearance of DTC P050A or related codes. After confirming connections, reset the engine control module, ECM, using the HDS, which helps in refreshing the system parameters post-repair. Following the reset, perform the ECM idle learn procedure, which establishes new baseline settings for the engine's idle condition. Once these steps are complete, turn the ignition to the on position and allow the engine to idle for 10 seconds or longer, monitoring for any DTC indications. This verification process serves to confirm whether the adjustments have resolved the idle air control system's issues, ensuring that the system operates efficiently in the future. Preventive maintenance is vital for preventing DTC P050A from reoccurring. Regular inspections of critical sensors such as the MAF and IAT should be performed to ensure they are functioning correctly. Dirt and debris can build up in the air intake system, so periodic cleaning of the air duct and air filter is necessary to maintain optimal airflow and performance. Additionally, performing routine maintenance on the throttle body can prevent carbon buildup, which can hinder air intake and idle control efficiency. Ensuring that all engine components are in good condition will help the vehicle maintain reliable performance, especially under cold start conditions. Proactively addressing these areas not only enhances performance, but also extends the lifespan of essential components within the PGM-FI system. In conclusion, DTC P050 is indicative of a cold start idle air control system performance problem that can significantly affect vehicle operation. It is crucial for technicians to systematically follow the outlined troubleshooting steps, beginning with a thorough assessment of the PGM-FI system, visual inspections, and component tests. Identifying faults in the IAC system, MAF sensor, or IAT sensor can lead to efficient repairs and restore optimal engine behavior. Additionally, ensuring regular maintenance checks and cleaning can prevent future issues from arising. The proactive management of the intake system and its components is essential for maintaining the performance and efficiency of the Honda Civic from 2011 to 2015. Ultimately, understanding these processes can lead to successful diagnostics and repairs, ensuring reliable operation of the vehicle. Please like and subscribe to the channel. See you next time.